Hello. Today we're going to go over section 3.1, solving systems using tables and graphs. This is systems of equations. You may remember this from geometry last year or algebra 1. Systems of equations are two or more equations for the same variables. In this lesson, we'll have two equations, both of them having an x and a y, because we're going to graph them. To solve a system of equations, find the ordered pair that satisfies all of the equations. And one way to do this is to graph the equations on the same coordinate plane. The point of intersection represents the solution. So basically, we're going to graph two lines and find out where they cross, if they cross. Okay, so let's solve this system of equations by graphing. We have two equations here, both with x's and y's. So that's a system of equations. And both equations are in slope-intercept form. So let's graph each equation. Let's start with this one, y equals x minus 4. So we have a y-intercept of -4. We start at 4. At -4 on the y-line, our slope is 1x. That means we go up 1 to the right 1. And when you're graphing on paper, this is a little different than when you're using Math Excel. When you're graphing on paper, it's always a good idea to mark each point for your slope and then connect the whole thing with a line. It's because you kind of want to be pretty precise about this. I know precision is always important in math, but to be able to tell where your line crosses is important to solve these. So going with the next one, we're going to start at +4, and this time we have a slope of -1, which means we'll start here at +4 and go down 1 to the right 1. Then we cross all our lines. Now, the solution is where the two graphs intersect. So right here is your solution to this system of equations, and that point is 0, 4. That's your solution. Okay, let's go a little more complicated. So now, let's solve this system of equations by graphing. We have x minus 1 equals -1. We also have 2x plus 2y equals 10. Both equations have an x and a y, so we can solve this by graphing. Now it says here to write each equation in slope-intercept form, but if you remember how to graph using intercepts, by all means go ahead and do that. Let's turn x minus 1 equals -1 into slope-intercept form first. So the first thing we're going to do is get rid of the x. That's a positive x, so we're going to subtract it on both sides, which leaves us with -y equals -x minus 1. You can technically write -1 minus x, although slope-intercept form is y equals mx plus b, so we do want that x first. Then our y is not all by itself. It's got that negative in front of it, which is the same as -1 times x. So we need to divide everything by -1. And we get y equals x plus 1 because two negatives make a positive. So we start at the 1 on the y-line. And then our slope, once again, is up 1 over 1. So we put all our little dots. And we connect it with a straight line. Now let's do this other equation. We have 2x plus 2y equals 10. We want to get rid of that x first. So we subtract the 2x from both sides. That gives us 2y equals -2x plus 10. Our y is not all by itself yet. We have to divide off that 2. So we're going to divide everything by 2. And we get y equals -x plus 5. Okay, we're going to start at the 5 on the y-line. Then our slope is down 1 over to the right 1. So we have a negative x slope. And we connect with a straight line. Now to figure out where the solution is, we have to look at where they intersect, right there. And the graphs intersect at the point 2, 3. Remember, it's alphabetical order, x, comma, y. All right. So let's talk about classifying systems of equations. So a system of equations will either have one solution where they cross once, infinite solutions where they're just one line laying on top of another line, so they cross at all of their points, or parallel lines where they don't cross at all. You will not have two straight lines cross twice, or 3 times for that matter. So it's just once, infinitely many, or none. If our lines cross at least once, so if they're one of these two, the infinitely many or ones, then they're consistent. There is a solution. If they don't touch at all, those are parallel lines, and there is no solution. Those are inconsistent lines. So let's talk about these consistent lines. We have 2 of them. The first one is independent. It's where we have one line, it crosses this other line, they say hello, and keep going. It's sort of like when you meet somebody who has different opinions and different beliefs than you, and you don't want to spend all your time with them. You meet them because we are polite and civilized people. We say, oh, that's very interesting, or something along that lines, and we say, okay, have a great day, and we move on with our lives. We don't get snarled or tangled up. We just go on because we are independent thinkers and we can think for ourselves, and we just don't need that. So one solution, we cross them once and we keep going without any other trouble. We are independent. And then right here we have dependent. And we all know that one person who's playing video games in somebody's basement, not really working, kind of there when you're, eating so that he gets some food. He's a dependent. He's just laying around on this other line, waiting for all the good things to happen. That's dependent. Okay? Now let's do a little bit of classifying. So let's graph the system of equations and describe it as consistent and independent, consistent and dependent, or inconsistent. So let's write each equation in slope-intercept form. So here's our 6y. We want to go to the x, get rid of that first. That's a positive 9x. So we're going to subtract 9x from each side. That leaves us with negative 6y equals negative 9x minus 6. We need that y all by itself, and that negative 6 is stuck to it, so we need to divide it by negative 6, divide everything by negative 6, and that gives us y equals 3/2 x plus 1. 9, 6 we have over here, 9 on the top, 6 on the bottom. 3 goes into 9 3 times, 3 goes into 6 twice. Now let's do the next one. Here's our y. So we want to go farther away from the y to this 6x and get rid of it. It's a positive 6x. So we subtract 6x on both sides. That leaves us with negative 4y equals negative 6x minus 4. We need that 4y to go away. We're multiplying here, so we need to divide everything by negative 4. Negative 6 divided by negative 4. Well, 2 goes into 6 3 times, and 2 goes into 4 twice. So once again, we get y equals negative 3/2 x plus 1. Since the equations are equivalent, the graphs are the same line. So there we go. Those two lines are right on top of each other. Any ordered pair representing a point on that line will satisfy both equations. So there are infinitely many solutions. So this system is consistent and dependent. It's just laying right on top of it. Okay, let's do another one. Let's graph the system of equations and describe it as consistent and independent, consistent and dependent, or inconsistent. Oh boy. Okay, so we have 15x minus 6y equals 0. So we're going to get rid of the 15x first. We subtract it because it's positive. And we end up with negative 6y equals negative 15x. So we need to divide both sides by negative 6. And we get y equals 5/2 x. Because 3 goes into 15 5 times, 3 goes into 6 twice. So there's one equation. Pay no attention to this extra equation yet. So over here we got the y. We need to get rid of the 5x, so we subtract it from both sides. We get negative 2y equals negative 5x plus 10. Then we're going to want to divide everything by negative 2. And here it is, the other equation. Y equals 5/2 x minus 5. And you should notice that, hey, they've got the same slope. And we learned in the last lesson, right before your test, that same slope means that we have parallel lines. And parallel lines do not intersect. So there are no solutions and the system is inconsistent. Okay, I think that's it for today. I hope you guys behave yourselves. I'll be back tomorrow. Yeah, good luck and have a great day.